1300 was there after what? One day. So 1 times that is K. We have this. Divide by 1000, divide by 1000. 1.3 equals this. ln. This K is going to go in front. So we're going to have K ln of E. ln of E is a 1. So we have, let me write those formulas again. ln of A to the N is n ln of A. And ln of E is a 1. Alright, so now we have the formulas right there that we used. So we have K times 1 is K. K equals this. So how do you find that? Do it in the calculator? Sure. So let's go. ln 1.3, close it. It's 2623. Yep, that's it. Got it. So now we know that n of t is this. And what happens? We now know 2 days. What happens after 2 days? Put a 2 in there. Put a 2 in there. So we're going to have all this. Use a calculator. Yes, of course. In fact, we'll do that right now. We're going to say 1000 second ln e to the power of 0.26236 times 2. Close, close. So we ended up with 1689.98, which is that number right there. So we have this answer all around it. How long will it take until the mosquitoes? There are 20,000 of these mosquitoes or lice or whatever they are. 20,000 equals this, divide by 1,000. And you take the ln, and what do you know about this? Yep, it's going to go in the front. And ln of E is what? Yep, it's a 1. So now we have 1 times this is this, ln of 20. So now we divide both sides by the decimal number, 0.26236, that way there. So this is going to end up with this. Can I do it in the calculator? Yeah, sure, of course. ln of 20 divided by 0.26236, enter. 11.418, some other numbers. All right. Let me see. Let me check this number again. 26,236 divided by 41,840,324. And you said it's 11.4. So let's see. 11,41840. There's a 4 missing right here. 40. Okay, now I got it for this machine. Okay, good enough. Next one. The half-life of carbon-14 is this. If a piece of charcoal made from a wood that 79% of it is still left in there, how old is a piece of wood from the tree? Alright, half-life formula, there it is. 7900 of this, divide by 100, divide by 100, 0.79 is this. And the power right there, you know where it's going to go in the front, because we said ln of A to the power is n ln of A. So now, this goes in front. So we have T 5600 ln of this, divide by ln of half, these are gone. So we have this left over. Multiply by 5600, these are gone. So we have all this equals T. Can I do it in the calculator? Sure, let's do that. 5600 times ln of 0.79 divided by ln of 1/2. And you ended up with 1904. Yep, close enough. There it is, and rounded off. The logistics growth model represents the population in grams of bacterium after T hours. There's a formula. So now, let's see how it goes. Determine the carrying capacity. Carrying capacity is this number right there. That's how many. That's the most possible ever, because of the food, because of the water, the environment. So it's going to be that number, 1,000. What is the growth bacteria? What is the growth rate of the bacteria? This number down here, 0.429, 0.429 is 42, 2 over 0.9%. That's how fast it's the growth rate. Now, determine the initial population size. P is 0. When it's 0, when you first did it, what happens? You can put this in the calculator. You're going to get that answer right there. Or round it to 31. What is the population for 9 hours? Same thing. Put a 9 in there, put this in the calculator, run it, you're going to get that answer. Or we round it off. When would the population be 700? So 700 goes this, cross multiply, 700 times that, now divide by 700, 700. 1 plus this number equals that. So now minus 1 minus 1. So this number equals that. Divide by 31.33, 31.33. We have e to this. Take ln on both sides. This number goes to the front. Ln of e is a 1. 1 times that. There is that number. This one, copy it, copy it, copy it. So now divide by negative 0.429. Negative 0.429. Cancel it. The calculator is going to give you this number, or you can round it to 10. Alright. How long does it take for population to reach 1/2? Well, 1/2 of 1,000 is 500. So again, set it up, cross multiply again. 500 times this, divide by 500, 500. These are gone. And so now we have this numbers. Subtract 1, we have this number equals 1. Divide by 31.33. 31.33. So we have this. ln, again, this is going to go where? Front. ln of e is 1 times that. That's it. And copy, copy, copy. Divide by negative, little minus sign, 0.429, little minus sign, 0.429. So we have this, or we have that, rounded off. The statistic model represents the percentage of households that do not own a computer. So in 1986, how many people do not own a computer? So P of 0 is, put it in there, put it in your calculator, run it, you're going to get 91.93, or 91.9 people did not have a computer or personal computer at the house in 1986. Now, that's T equals 0 is 1986. Next question is, graph this thing. Put it in your graphing calculator. Yes, these are the window you're going to use, negative 170, negative 10, and when you do it in there, it's going to give you this graph. It looks like this. It's going to start right there at 0, 91.9. It's going to go down, 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 down. Eventually, it's going to go closer and closer and closer to 0. So people that didn't have a computer, 91.9% didn't have it, and then 6 years later, 87 didn't have it, and then 21 years later, 52% didn't have it. 36 years later, 10% didn't have it. 50 years from there, only 1% does not have it, so on. Alright, so there's a year. 0 is that number, 6 is that number, 36 is that number. Percentage of households did not own a personal computer. It goes like this. Alright. What percentage of households did not own a personal computer in 1992? Well, in 1992, subtract those two numbers, 6 years. So P of 6 is that number right there, which is 87.7. Did not own a computer. How many? 87.7% did not. In what year would the percentage of households that do not own it be at 10%? So 10% of this equals 10%. Cross multiply. Divide by 10, divide by 10. So we have this. Subtract 1, subtract 1. So now we have this number to that. Divide, divide. E to this power equals this. Take ln, and you know that this number always goes in front. ln of e is 1. 1 times that. There it is. Copy, copy, copy. So divide by this number, divide by this number. This divides it. This divides ln of that. So we can get 35.91 years later, or round it off to 36, or add it to the original number, 1986 and 36, in the year 2021.9. 10% of people do not have a computer. Solve this. So what I'm going to do is I'm going to 2 and 1. I'm going to multiply these two numbers right here, flip them. 1 times that, 2 times that gives me this answer. So now add them straight down. 13x, 0, and that. 13x, 39, divide by 13, divide by 13, x equals 3. Put it back in the other one. 3 times 3 is 9. Minus 9 minus 9, so negative 2y equals negative 6. These cancel out, you have 3. So the answer is 3, 3 for the x and the y. Solve the system. Solve the system equation. Use your graphing calculator. Second matrix, edit A, enter these numbers. And then second matrix math, down arrow till you get RREF of your A. You're going to enter it, you're going to get all these numbers right here. Which is going to give you X, Y, and Z is that. Okay. Can we do it in the calculator? Sure, why not? Let's just try it to see what happens. Okay. Second matrix. Edit. A. 3 by 4. So there it is. Oh, we don't want that. I want 3 by 4. 3 by 4. There it is. Now it looks like that. Put the number in. We have 1. We have -2. We have 3. We have 11. We have 2, 1, 1, 7, and -3, 2, and -2, and -15. Uh-oh, error. Let's see what we did wrong. Second matrix, edit. A. Let's see what's in there. We have 1, -2, 3, 11. That sounds okay. Over here we have a 2, a 1, a 1, a 7. That's okay. And over here we have a -3. We have a 2. We have a -2. And we have a -15. Okay. So now second matrix. Let's see if it looks good or not. Let's just look at it. All right. So we have 1, -2, 3, 11, 2, 1, 1, 7, -3, 2, -2, and -15. Are those numbers good? Yep, they're good. So now, second matrix. Let's go to math. Let's go to RREF. Row reduction echelon form. And what is it? Second matrix of A. So hit enter, and we're going to end up with 3, -1, and 2. 3, -1, and 2 are the solutions to that. Find the sum. Do it the long way, or you can use a graphing calculator. Let's do that. Clear it. You can go math, move it down to summation. There we go. And inside the blocks, put the number. You have x, you have 1. On top you have 6, and you're doing 9x plus 8. So 9x plus 8 outside. Does that look like this? Doesn't matter. The letters, it doesn't matter. 237. Yes, 237. Alright, expand using the binomial theorem. So that means the way you do this is you're going to go for CNR is 40, x to the 4, x to the 3, x to the 2, x to the 1, x to the 0, and then 3 to 0, 3 to 1, 3 to 2, 3 to 3, 3 to 4. See the numbers? 4, 3, 2, 1, 0, 1, 2, 3, 4. So now, CNR 40, how do you do that? Let's do it in a calculator. Let's go for math, probability, NCR. There it is, I found it. And that's going to give me a 1. Second enter, you put the next number, 1. You're going to get a 4. Then put the next number in there, 2. You're going to get a 6. And then put the next number in, 3. You're going to get a 4. And then put the next number in there, 4. CNR 44 is going to give you 1. So we got all these numbers right here. And times them out. X to the 4, 12x cubed, 54x squared, 108x plus 81. And we're done. This one, rewrite it, put this number over here, square both sides. You have 2x minus 5 equals x minus 4, x minus 4. So we have this equals this. So now we have minus 8x. Bring this over to this side. So -2, positive 5. So now we have this. Now, can we factor this? Yes. 21 and 1, 7 and 3. We'll go 7 and 3. Minus, minus. X minus 3 equals this. X minus 7 equals this. Add 3, x equals 3, or x equals 7. Let's try, check. Does 3 work? Put 3 in the original problem. 2 times 3 is 6. 6 minus that is 1. Square root of 1 is 1. 4 and 1 is 5. Isn't that equal to 3? No, bad. Other side. Put a 7 in there. 2 times 7 is 14. 14 minus 9. Square root of 9 is 3. 4 plus 3 is 7. Is that equal to 7? Yes. Good, 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 good. So the answer is only 7. The other doesn't work. It's an extraneous solution. It means bad answer. Okay, that's it. We are done. Good luck, STEM guys. Good luck.